Hai, Assalamualaikum. Selamat malam. Kita sambung lagi ya untuk sesi kedua. Okay, the previous session I have discussed until number 20 ya for paper 1. So now I will continue with number 21 until number 40. Okay. Okay, we look at number 21 under topic of gravitation. Okay, satu satelit GSM-M beredar mengelilingi bumi. Orbit R mengambil masa T untuk membuat satu peredaran. Orbit R masa T. Satu satelit lain GSM-4M mengambil masa yang sama T untuk membuat satu peredaran. Jejari orbit satelit kedua. Okay. So given a satellite of mass M move around the Earth, radius R take T time, period T to make one revolution. Another satellite, another mass for M takes the same time T to make one revolution. Radius of the orbit of the second satellite is Y. So make sure you know what are the factors that affect period of revolution. Faktor yang mempengaruhi period atau tempoh. So actually this one you can look at Kepler's third law, which relates between period and radius of orbit. Okay. Period squared directly proportional to cube of radius of orbit. Okay. T kuasa 2 berkaitan langsung dengan R kuasa 3. Okay. So I hope you know how we get this relationship by using the centripetal force equals to gravitational force. Okay, so you get this one. And then you substitute B equals to 2 pi R over T. Okay, you try and see, you will get the relationship between T and R. T squared equals to 4 pi squared R cubed divided by Gm mass of Earth. Okay, 4 pi squared over Gm is a constant, so T squared directly proportional to R cubed. So because of this relationship, we can relate between T and R. Okay. So from here, you can see there's no factor mass of the satellite or objects or planet, just mass of Earth, which is always the same for both of the satellite, because both orbiting the Earth. Okay, so we can say that the change in mass does not affect period of oscillation. Okay, for the same orbital orbit, a radius of orbit. Ya. Okay, disebabkan R dia sama, maka period dia sama. GSM tidak mempengaruhi. Jadi jawapan dia adalah R. Okay, tak perlu nak calculate susah-susah untuk dapat. Okay, if you understand the factor that affect period in this case, okay, so you will get the answer C. Number 22, dua GSM M, small m and capital M dipisahkan dengan jarak D. Okay, the separation distance ialah D, masses M and M. Gravitational pull between them is F. Okay, dia bagi daya graviti F. Distance between them is increased to 4D. What is gravitational pull between them? So this one also is relationship between F and R. Gravitational force inversely proportional to the square of distance between centers of the two objects. Okay, I think same as number 21. So you have F1 over F2 equals to R2 squared over R1 squared, because the relationship is inversely proportional. So for the distance D, the gravitational force is F. So what is gravitational force when distance is 4D? So we can substitute into this formula. Kita saja. Okay, F1 is F, F2 is we want to find, R2 is 4D squared, and then this one is T squared. Okay, so we get F over F2 equals to 4 squared is 16, D squared will be cancelled, so we get 16. So F2 equals to 1 over 16F. Okay, jadi kena tahu tulis ni supaya lebih mudah pengiraan. Okay, daripada hubungan ini kita boleh dapatkan satu equation. Then we get the answer is C. Tajuk gravity you all kena try banyak soalan, especially calculation. Okay, number 23. Diagram 11 shows a tunnel through center of the earth O from point X to point Y. This is center. Assuming that Earth is uniform sphere, which graph shows that gravitational field strength E from X to Y? Alright, formula. What formula that we can use to relate? Nak lihat apakah yang berlaku kepada nilai G, small g daripada X kepada Y. Ini adalah center pusat graviti. Okay, mg equals to G mm over R squared. So we have G Gm over R squared. Okay, so means G squared. So at the radius of the Earth, at the surface of the Earth, I think you remember the value 9.81 meter. So what happens at the center? Okay, from X to O, we can look at the graph here. The value of E, unit, okay. If I hope you know the unit E is okay, Newton to kg. Okay. Actually same as G ya, unit dia. Sama. Okay. So at the center of gravity, the value of G will become 0 here. So it means the value of G at the surface of the earth is the maximum value, 9.81. Yeah. Okay. So it will decrease to 0. And then from O to Y, increase again, become 9.81. This is what happens from X to Y. Okay. So the graph, which is best describe what happens to gravitational strength, is D donkey. Okay. Number 24, diagram 12 shows ice cube being heated by 600 watt immersion heater for 60 seconds. The melting ice cube are collected in a beaker. The specific latent heat of fusion of ice is 3.3 times 10 power 5. So ini ialah tajuk heat. Dia diberikan kuasa pemanas 600 masa 60 second. Okay, haba pendam pelakuran ais juga diberikan. Okay, soalannya ialah hitungkan jisim ketulan ais yang telah dileburkan, maksudnya yang telah berubah menjadi air. Calculate the mass of ice cube which have melted. Okay. Formula. Okay. PT ml. Power ialah 600, time taken 60. So we get this formula. Heat supplied by heater equals to heat absorbed by ice. The heat absorbed will cause ice to melt. So we can use PT equals to ml. So you substitute. P power dia 600, time taken 60 seconds, mass, and then the specific latent heat of fusion. Okay. So you can calculate for M. So M is the mass of ice that melted. So M equals to 0.109 kg. The answer is okay, number 25, diagram shows Ali is sitting near a campfire in igloo to warm up his body. Okay, nampak gambar What happens when thermal equilibrium is achieved? Apa berlaku bila keseimbangan thermal tercapai. So I hope you understand what is the meaning of thermal equilibrium. Thermal equilibrium is the situation where the heat transfer between the two objects become equal, or the net rate heat of transfer between two objects is zero, and they will reach same temperature. Okay, that one they call it thermal equilibrium, keseimbangan thermal. Okay, ini yang pertama salah. Okay, which one is the best answer? There is no net flow of heat between air inside the igloo and Ali's body. Okay, right? The net flow of heat from air inside igloo to Ali's body. Okay, so answer is C. Ini ialah pemahaman tentang definition untuk thermal equilibrium. Number 26, diagram 14 shows water wave that are travelling from sea to shore. Okay, boleh nampak ada cape dengan bay, teluk dan juga tanjung. Okay. Which wave properties at the cape and the bay are correct? So you can see there's a change in depth, change in depth. As we know that depth will affect velocity or speed and wavelength. Okay, so the shape of the wavefront that reach the cape and bay area, you can see it will curve and follow the shape of the beach. Okay, so at cape, you can see here, direction shows the wave is converged there. Converge means the energy will be accumulated here. Okay, dia converge menumpu, jadi tenaga gelombang akan berkumpul dekat cape. Amplitude become very high, so it's a bit wavy here, lebih berombak kawasan cape. Kalau you tengok bay di sini, direction dia nampak diverge, diverge. Dia tak converge, dia diverge. So means the energy will be spread, okay, to larger area. So amplitude is smaller. So it's more, we can say like calm water, air lebih tenang sini dekat bay banding dengan cape. Okay, so cape area, what happens to cape area? So we just choose the best answer. Energy is focused. For bay area, wavelength is shorter. Okay. Number 20. This is number 26. Okay, we get from diagram. Okay, the wavelength is shorter. Energy is dispersed, means spread, spread to larger area. The wavelength, you can see the distance between two wavefront represent the wavelength. So we answer based on the diagram given. For number 27, diagram 15 shows water waves that are passing around a small island. Okay, the question is, you can see the when wave, okay, coming from here, so it will round the island and spread over here. Okay, so what is this phenomenon about? Ini berkaitan dengan apa? Okay, so this one we call it diffraction. Okay, berlawan, berlawan, berlawan. Because the water wave round the small island and spread. Okay, penyebaran gelombang. Okay. So which physical quantity change? Jadi gunakan V equals to F lambda. Okay, tiada perubahan pada speed. No change in speed because no mention about change in depth. So ini tak ada. Okay, there is change in energy. Yes, because it spread to larger area, energy dia juga akan disebarkan. Kalau energy dia spread, amplitude pun sama because the amplitude depends on energy. Okay, so jawapan dia ialah C. 2 dan 3, 2 and 3 only. Number 28, diagram 16 shows fringes obtained when red light used by a student in young double slit experiment. Okay, ni eksperimen visual layang. Tajuk apa ni? Interference. Okay, interference. So, young double slit. Okay, menggunakan cahaya merah. Which pattern to observe when red light replaced by blue light? Okay, so we use monochromatic. Monochromatic is the light with one color, meaning one wavelength. So you kena tahu arrangement, red, orange, yellow, green, blue, indigo and violet. Okay, merah, orange, kuning, hijau, biru, indigo dan violet. Dalam bahasa Melayu lah violet. Macam mana Okay, dia punya perbezaan dari segi panjang gelombang. Red ini wavelength paling panjang. So from red to violet, lambda decrease. So if you compare between blue and red, blue, red, so lambda of blue is shorter than lambda of red. Okay, panjang gelombang biru lebih pendek berbanding panjang gelombang merah. Okay, so the distance between two consecutive fringes, kalau ini adalah red, maksudnya ini red, 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 red. Okay, bright, dark, bright, dark, bright, dark, so on. So ini distance dia adalah X. Okay, untuk interference formula, kalau tak ingat tengok list formula, D lambda over A. Okay, factor D and factor A constant. So hanya relate between X and lambda. X dengan panjang gelombang. Kalau gantikan merah dengan biru, red with blue you replace, means the lambda will decrease. When lambda decrease, X also decrease. So you will observe the fringes become closer when you replace with blue light. Which one shows closer compared to the red one? This is red. Okay, so I think A is better. You can see the distance between two blue fringes. So all these are blue color. Ini semua adalah biru. Okay, ini X tu menjadi lebih pendek. Okay, sebab tu formula is very important. Kalau you lupa, pergi lihat this semula. And now we look at 29. Diagram shows a ball floating in water tank. Okay, nampak ada bola dalam satu tangki air. Which diagram shows correct movement of ball when the wave passes through it? Okay, ini adalah wave Water wave is example of, ini kita panggil transverse wave. The ball we can assume as like a molecule of water. So once the wave travel here, what happens to the ball? Does the ball move along with the wave or it just stay here? So okay, back to the definition for transverse wave. Okay, molecules of medium vibrates perpendicular to direction. So means if you have molecule of water here, it will vibrate up and down at the same position. It does not move with this water wave. Same thing happened to the ball. The ball will move up and down, up and down. Okay? Okay. So from here we can see the answer for number 29 is D donkey. Okay? Number 30, diagram 18 shows a man stranded on an island 500 meter from a cliff. Okay? Dia terperangkap di pulau 500 meter daripada tebing sini. You can see the man shouting. Okay, soalan. He shout for help, but all he can hear is reply is the echo of his shouts from the cliff. What is the time interval between the voice shouting and hearing of the echo? Okay, dia meminta tolong, menjerit minta tolong, tapi apa yang dia dengar adalah suara dia balik datang. Maksudnya gema ataupun echo. Echo is a reflected sound wave. Macam you masuk dalam gua, you cakap, macam ada orang cakap balik pada you. Actually that one is echo ataupun gema yang kita panggil juga reflected sound wave. Pantulan gelombang bumi. Okay. Okay, soalan ini kita nak cari time interval, okay, between the voice shouting and hearing the echo. Speed of sound given. Okay. Kita ajar tadi okay, semua. Okay, the voice and this is the rock. Okay, 500 meter. Okay, the voice shout, the sound wave will travel 500 meter and hit the cliff here. And then the reflected sound wave will travel 500 meter and come back to the person. Okay, so what is the time interval between voice shouting and the hearing of echo? Okay. From the formula, okay. So because of the distance 500, Normally when we record the time taken, we record for two-way, pergi balik, because the person hear the sound after T second. T second is for to and fro, pergi balik. Okay, that's why here kita ada divide by 2. Actually, the basic formula ialah V equals to S over T, where S equals to dt. Okay, so for distance D, the time taken need to divide by 2. Okay, so we get this one. So you substitute, you will get T equals to 2.94 seconds. Okay. Okay, 31. Diagram shows water wave travelling from deep area to shallow. Okay, kawasan dalam ke kawasan cetek. Okay, ini ialah incident, incident. Okay, gelombang 7. Jadi angle sini angle I. Angle of incidence. So from deep to shallow, what happened to speed? Okay, the speed will decrease. When speed decrease, it will bend towards normal. Bends towards normal. So which one bends towards normal? Okay, you must understand the concept of refraction. If no refraction, the wave will travel in the straight line like this. If no refraction, straight line. Okay, if the speed decrease bends towards normal, means the refracted wave must be in this area. Must be in this area. If refract away from normal, it must be in this area. So that's the reason why the answer must be B void. Okay, jawapan dia B. Number 32, diagram shows interference pattern of two coherent water wave sources X and Y. Okay, at which point A, B, C, D does destructive interference occur? So you must understand constructive, membina, constructive ialah di antara crest and crest or trough and trough. Okay. Maksudnya puncak dan puncak, lembangan-lembangan akan dapat konstruktif atau membina. Kalau destruktif, hanya satu situation saja. Crest meet trough. Puncak bertemu lembangan akan dapat membinasa, lembang interference memusnah atau membinasa. Okay. Jadi di sini dia bagi key dia, kena lihat betul-betul key dia. Untuk yang broken line ni ialah trough. Untuk yang full line ni ialah crest. Okay. Jadi boleh check satu-satu. Kalau A tu ialah trough and trough. So ini adalah constructive atau membina. Kalau B tu ialah crest and trough. Ya, betul. B. C di sini, ini tak nampak tapi adalah masih lagi membina, dekat dengan kawasan membina. Okay. D also membina atau konstruktif, crest. Okay, ini jawapan paling baik ialah D, Okay, number 33, number 33, this is electromagnetic spectrum. What spectrum components are X and Y? Okay. Gamma, kena ingat susunan, Okay, gamma and then kita ada X-ray. Kita ada ultraviolet, visible light, ini ialah infrared, ini ialah microwave and radio wave. Okay, jadi kena ingat susunan dia. X ialah ultraviolet atau ultra ungu. Y ialah ultraviolet atau ultra ungu. X ialah infrared atau inframerah. Jawapan dia B. Okay. Number 34. Water wave moving through a gap. Nampak? Kalau gap macam ni, automatically ialah pembelauan ataupun diffraction. Okay. You can see the wave spread after passing through a gap. So ini diffraction. Okay. Which statement about diffracted wave is true? First, the effect of diffraction of water wave more obvious when size of gap is wider. No, should be smaller. Amplitude of water wave is smaller than incident wave. Yes, because the water wave spread to larger area. Energy per unit area of diffracted wave is the same. No, should be smaller. The speed of diffracted wave is more. No, should be same. Okay, so answer is B point. Amplitude of the water wave is smaller than the incident wave. Sebab dia tersebar ke kawasan lebih luas, tenaga dia telah tersebar pada kawasan yang lebih luas, so the amplitude depends on energy. That's why amplitude dia adalah lebih kecil. Nombor 35. Diagram 23 shows apparatus setup of an experiment to study interference of light. Wavelength of monochromatic light is 6.5 times 10⁻⁷. Distance between two slits given. Distance between double slit and screen also given. So ini berkaitan dengan interference cahaya or interference of light. Jadi formula kena tahu, X equals to D lambda over E. Formula interference. Okay, tengok diagram. Okay, the separation between the two slits. This is A. From the double slit to the screen. This is D. Okay, distance between two bright fringes or dark fringes is X. Okay, soalan. What is distance between two adjacent bright fringes? Means X. Okay, dua pinggir cerah berturutan. Okay, kita nak cari X. Okay, wavelength dia dah berikan lambda 6.5 times 10 to the power -7. Okay, lambda. Okay, distance between two slits A 0.4 10 to the power -3. Capital D distance ialah 3 meter. Okay, semua unit meter. Okay, senanglah kalau semua unit meter. So you better check kalau unit tak sama, you kena tukar dulu. So X equals to D lambda over A. So kita substitute, ganti je. Tapi make sure unit sama. Kalau tak sama, tukar. Okay. Okay, dia dapat jawapan ni ialah 4.9, buat rounding off sikit. Okay. Okay, number 36. Interference pattern. Okay, corak interference. Okay, nampak dia crest, puncak. Okay, dia tunjuk untuk crest saja atau puncak saja. So kita ada source 1 and source 2, coherent sources. What is wavelength of the waves? Okay, formula juga sama. So separation between two sources, ini ialah A. Distance between sources and the line where X is measured. Ini ialah X. Ini D. Kita panggil D. Distance between two wavefront. Ini lambda. Okay, sekarang kita nak cari lambda lah. So, from X equals to D lambda over A, lambda equals to AX divided by T. Okay. So, lambda sama dengan A berapa tadi? Gantikan. Okay, so now the unit all centimeter, also same unit, so it's quite easy. X 2.5 and then 8. Okay, so we get 0.625 centimeter, rounding off 0.63 centimeter. Number 37, diagram 25 shows glass of water placed in front of piece of black and white colored paper. Okay, nampak gambar dia. Okay, soalan. Which light phenomenon explain the situation? Okay, kalau ada glass and then the glass filled with water, means the light travel from air to water, different density of medium. So this one will cause a refraction to occur. Ada change in density of medium, air to water. So refraction, pembiasan. Nama DA, ini adalah sound wave. Sound wave, speed 330. Sound wave travel longitudinal way, sound wave ni, longitudinal way. Gelombang membujur. So longitudinal wave, it will cause air molecules to vibrate horizontally or parallel to direction of wave. So ini direction of wave tu. So molecule dia vibrate, left and right. So this one will produce compression, rarefaction, compression, rarefaction, compression region. So distance between two consecutive compression region, we call it lambda. So from here we can see the lambda is 1 meter. The question, what is frequency? Dia nak kamu kalkulakan frekuensi gelombang. Formula B equals to F lambda. So F equals to B divided by lambda. 330 divided by 1. 330 hertz. So we can answer in C. Number 59. Which physical quantity decrease when water propagates to a deeper area? Maksudnya bergerak daripada kawasan yang cetek ke dalam. Deep, shallow to deep. As we know, from shallow to deep, velocity or speed increase. Frequency is constant. Thus, lambda increase. B directly proportional to lambda. So physical quantity that decrease in this case is frequency, no. Wavelength increase, speed increase. So the amplitude. Yeah, because when propagate to uh, for distance, because of the frictional force and all that, some of the energy will be lost along the way. Tenaga dia akan hilang. Okay. Kalau you nampak wave dari tengah laut tu tinggi, tapi bila sampai ke depan tu amplitude dia pun dah jadi rendah. Okay. Jadi sama juga kalau dia bergerak sudah jauh, jadi energi dia semakin hilang. Okay. Jadi ini amplitude dia sahaja yang okay. Soalan yang terakhir. Diagram shows a dolphin which is able to locate a small fish. Which wave phenomenon is involved? Okay, so dolphin will produce sound which is known as ultrasound. Okay, ultrasound. Very high frequency sound, more than 20 kilohertz. Okay, this is inaudible sound. Inaudible maksudnya tak boleh dengar, manusia tak boleh dengar sound tu. So this ultrasound, one hits any object, it will bounce back. Ultrasound ni kalau dia kena pada objek, dia akan pantul balik. Okay, jadi dolphin ni bila dia keluarkan, okay, kena pada ikan, so dia akan pantul balik. Okay, kalau dia keluarkan, then dia ada can detect the sound that coming back means there must be object in front. So this is the fish, the small fish. Okay, that's why it's able to locate small fish. So this the concept is reflection. Okay. Okay, so that one is paper 1, number 21 to number 40. Okay, so if you have question, then you can write in comment. Okay, or if you are online now with me, you can write your question now. Okay. So I think that's all my session today. So I have done for paper 1 as a revision for Form 4 syllabus. Okay, so that's all. Bye.